Today we are going to start with the remaining part of control statements. Here we will see some remaining examples of for loop and then jump statements. So we will see, we have already seen one example of for in the previous video. Now we will see one more example. In this example, all the control variables to control the for loop needed will be declared and defined in the for loop itself. So I will create package. The variables needed in for loop, you can declare them before for loop also and inside the for loop also. So we will see the example with the variables declared inside the for loop. Now I create one for loop for int n is equal to 0, n is greater than 10, n is greater than 0, n minus minus. Now I will run this code. The same output will be there, but the difference is that this declaration and definition is done inside for loop only. Now we will see one more example of for loop. Initialization part and increment decrement part can have more than one variable at the same time. So for that, I will create one more project. Usage of comma for with comma table. New package. Now I will create one example, one class, comma. Here I will create two variables, int a, comma b. For example, a is equal to 1, b is equal to 4. This example we have already seen in theory part. Here we are using its practical part. A less than b, comma b minus minus. So this is the initialization part. Here I have used two variables instead of one, and here also I have used two variables with increment and decrement instead of one. So that is made possible because of comma. Now I will run this program. First of all, A is initialized to 1, B initialized to 4. So output of A is 1, B is 4. Next time, after this execution is completed, A is incremented by 1, A plus plus. So what is A now? A is 2. And what is B now? B is 3. So A is 2 and B is 3 is printed. Again it is incremented. So now A will become 3 and B will become 2. So 3 less than 2. No, this condition is not satisfied. So it will come out of for loop. So this is the usage of comma to have multiple variables in for loop. We will see one more example. For loop variation. In different ways we can use for loop. We can create and use for loop. We will see one more example for this closed project. For variations demo. I created one Java class. Now I create one variable int I and boolean done is equal to false. I is equal to 0, initialized to 0 for first part is empty because I is already initialized. Then not done means unless and until value of done is true and remaining part is blank. So for that remaining part is blank, that I will be incremented inside like it while loop. Okay. Now I will print I is just a minute. Will print I is value of I and if I is equal to 10, I is equal to 10, done is equal to true. So why I am making this done is equal to true? This is the end condition of this for loop. Okay. Here, first of all, done value is false. Okay. So what is my condition? Unless and until value of done is true. Not false is equal to true. So every time after printing this I, it will be printing 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9. And at one point it will become 10. So after it become 10, the done value will be true. And after done is true, not done will be false and it will come out of for loop. Okay, so this is the stopping condition. It is very important. And why this is called as for variation? So it is increment and decrement part plus initialization part is included here. But how? First part is empty, end part is empty. But first part is written before for loop and end part is written inside for loop. So it is present there, but you can write in this way. This is the motto of this project. Why we are created this for variation demo project? To understand that we can use in this way. Okay, so now I will run this code. After 10, done will become true, not done will become false. So unless and until this is false, it cannot go inside. This condition must be evaluated to true always. We will see one more example of for, that is nested loops. How one for can be written inside another for loop. Nested for loop demo. Package for nested for. I will create nested for class. Now in this main function, I will create two variables, int I, comma j. Okay, so initialization part is done inside for loop. For I is equal to 0, for example, I less than 10, I plus plus. Why we are using nested for loop? We can use for nested for loops in arrays. 2-dimensional array, 3-dimensional array, and so on. In 2-dimensional array, for example, number of rows will be iterated in outer for loop, that is i's for loop, and inner for loop will be iterated in the inside j's for loop. So this way we can use this nested for loop example. J less than 10, j plus plus. Sorry, j is equal to I, j less than 10. So every time I is there, that number of j will be there. For 0, this number of stars will be printed. We are printing over here stars. Printing star and then printing new line. Let us run this code. Okay. So when it is 0, I is equivalent to I. Sorry, j is equivalent to I. So when I is 0, j is also initialized to 0. From 0 to 10, 10 times star will be printed. Inner loop is finished. Now I is 1. So from 1 to 10, that is 9 stars will be printed. So we will count the stars: 1, 2, 3, 4, 5, 6, 7, 8 and 9. So this way outer for loop and inner for loop combinedly creates this star structure. Okay. So this is the usage of nested loops. Now we will see some jump statement examples. We will close this one. We will start with break. So break loop demo. The first uses of break is we have seen in the theory part, that is using a break to exit a loop. New class. So what will be my class? Break loop with main function. So now I will try to exit a loop using break. Let's see what happens. I will create one loop for I is equal to int I is equal to 0, I less than 100, I plus plus. This is just an example. For if I is equal to 10, I need to stop this loop. Okay, so it will terminate. It will terminate if I is 10. So after 10, this loop will not complete, will not iterate. Okay, and then I will print I. Why I will print I? Other than I is equal to 10 cases. If it is not 10, up to 10, it can print value of I. So I is and for loop. Now I will try to run this. So in this for loop, actually condition is specified here, I less than 100. But this loop will not iterate 100 times. Why? Because of this break. If I becomes 10, I will break out of this loop. So it will come out of this loop and it will print for loop complete. Otherwise, if I unless and until I becomes 10, it will print. This condition is not satisfied from 0 to 9. So from 0 to 9, it will print the value of I. So this way, this is the usage of break. Now we will see next example. Of breaks. break loop 2. So you can use break with while loop also, not only for loop. So we will see break with while loop. Now I will use while instead of for. So initialization part is done before while loop, as we have seen in while syntax. If I is equal to 10, sorry, break. So here terminate like a for loop. Otherwise I will print I is plus value of I, then I plus plus. This part is done here because this is not a for loop, this is while loop. Initialization before while, then condition and increment decrement inside while loop, and after that loop complete. So let's try to run this code. It will produce the same output as for loop. Only difference is that we have used while instead of for. Now we will see third example. In this third example we will try to see that if I use nested for loop, how break will operate. Okay, so this is my third break loop. Break loop 3 class, public static void main. Okay, now I will create two for loops. For I integer I is equal to 0, I less than 3, I plus plus. Then pass value of I inside second for loop. I will provide int j is equal to 0, j less than 100, j plus plus. If j is equal to 10, sorry, j is equal to accidentally we can write here is equal to, still it is throwing an error, but it is not a condition check, it is assignment. Is single is equal to is assignment, so I by mistake written here equal to, it should be equal to. If j is equal to 10, then I need to break the loop, terminate, but this will terminate this inner for, not outer for. Okay, So break is directly related for loop. Okay. Then system.out.println. J is plus J. Now it's after that this outer inner for loop will finish, and only new line is needed over here. And after this outer for loop is also complete. For loop complete. Outer. Okay. Now I will run this. So first of all, 0th pass, I want output up to 10 only. Okay. So if it is iterating 100 times, when j will become 10, it will break. So it will print from 0 to 10. For pass 1, it will print 0 to 10. For pass 2, it will print 0 to 10. That is less than 10, 9. And after this, for loop is complete. So we have already seen break in nested for loop. In nested for loop, only innermost for will that is directly related to this that break will terminate. Okay. Now we will see using break as civilized form of goto keyword. Okay. So goto is not used in Java, but still using break we can use the goto as a civilized form of break as a civilized form of goto. Break demo as goto. New class break as goto. So in the theory part we have seen how to use break as goto. For that we need to create a label. For that particular label, after execution, if I specify break and then label name, so that particular block of code containing that label will be break or will be terminated. This is my first label, first, then second, then third. So I created 3 labels. Okay. Now before the break, then if T break second, what is this break second? This will break the second loop. Why we have used this label? In the previous example we have seen in nested loops only the innermost loop, that is directly related to break, in which we are using break, that will only be terminated. But here I need to terminate the second outer loop after this third loop. Okay. If I will not specify this second, it will break this third loop. Okay. So for that purpose, I need a label. So for I created a label, and if T is equal to true, I need to break the second block. This won't execute. So after third one, so after terminating second, whatever is written that can be executed. So this is after second block. This can be surely executed. Now I will run this. Before the break is displayed, and T value is checked. T is already true, so it will break the second. So after breaking, this won't execute. Number 1 is not executed. We will give it a number so that we will understand it properly. Okay, we will check if it is working. This is after second block. This can be surely executed. So these 2 lines are never executed. Okay, so we can use always break as a civilized form of go to. Now we will see one more example. To use break to exit from a nested loops. This is very simple example. Here I create one label, outer, for int I is equal to 0, I less than 3, I plus plus. same example is repeated, but to understand the usage of break, to exit from a loop, if j is equal to 10, break outer. Okay, so this will break the outer loop, exit both loops, and then j not created, because we are breaking in, not breaking inner, we are breaking outer. Now we will try to run this. Only one pass is taken and we are breaking both the loops, so it will not iterate for 3 times. Now we will see one bad practice that who do not understood break properly. So break with error, we will see. I create one block or int I is equal to 0, I less than 3, I plus plus. So 1 is declared here, okay, and it contains pass, like in the previous example, I, then colon. Then next for loop is defined here. For integer j is equal to 0, j less than 100, j plus plus. Okay. If j is equal to 10, break 1. This will give me an error. This is a wrong practice. Why it is a wrong practice? Because this for loop is written after this. So it is not included in this label. So we cannot break this label from outside of this label. Okay. So if I write here, I cut this code and again write here, it is possible. And I print j plus space. Now this is correct. Okay. So what we have seen in this example, you cannot break the label outside of that block or that made for that label. Now we will see some examples for continue as well. Continue demo. I will create a class. Look at this. I have not created a name as continue keyword because spelling is different. C is capital. If I write here like continue is not valid identifier because continue is a keyword. Okay, so remember while creating a program, the Java file name and class name should be the same. Also, first name of Java file or class should be capital. You see the uses of continue over here. So how continue is used for int I is equal to 0, I less than 10, I plus plus. System.out.print I plus space. If I module 2 is equal to 0, then continue. Otherwise print new line. Now I will try to run this code. So 0 is printed. 0 module 2 is equal to 0 checked. 1 module 2 is equal to 0 checked. Every time the value is checked, if 0, it is 0, then continue. So it will continue and write here output. Then after that it will come to the new line 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we will see continue with label. As break with label we have already seen. Continue with label. For int I is equal to 0, I less than 10, I plus plus. Then for int j is equal to 0, j less than 10, j plus plus. if j is greater than I, new line, and then continue outer. You can see the keyword written in red. So everything that is written in red are keyword. Public is a keyword, class is a keyword, static is a keyword, void is a keyword. For, int, if, all are keyword. You cannot use this keyword as it is with same spelling anywhere in your program or in your project. I'm printing space plus I into j. So let's see what happens in this case. So first of all, I is 0. Then j is also 0. J is greater than I? No, 0 is equal to 0. So it will print a line, new line, and continue outer. Okay, so j is not greater than I, so it will not go inside. It will print I into j, 0 into 0. Then for the next line, I will become 1 and j will become 0. So j is greater than I? No, 0 is not greater than 1. So it will print what? 0 into, sorry, 1 into 0. It will print here 0. Then for the next part, now j will become 1. Okay. So 1 is greater than 1. 1 greater than 1, false. So it will print here 1 into 1. It will print here 1. Then 2. 2 is greater than 1. Yes. So it will print new line. It will come to new line and it will continue outer loop. So this loop execution is finished here. It will go again here. So now I will become 2. So for 2 and 0, 0 is greater than 2. No. So it will print 0 into 2. Then 2 into 1, that is 2, and 2 into 2, that is 4. So this way all these values are printed. So how smartly we can use these labels like keywords, continue, break, and return jump statements to create a smart output. You can see. Okay. So lastly, we will see the return. That is the only remaining part of control statement. All else is done. You will see the return demo. Actually, at every method call, return is present, but we cannot see that return. By default, it is present. But when we need to explicitly return from anything, any block of code, so we can write over there return keyword. Here, I will write before the return. If true, return. And this will return caller. And after this, whatever is written here will not be executed. This won't execute. Only the before the return is executed. Why? Because return will return control to the caller, and whatever is written after this will not be executed. So this way we have finished all the control statements practical part 2. In the next we will start with the basic, very much interesting, very much important topic of Java, upon which the entire Java has been built, that is called as classes and objects. So classes and objects are very much important. You need to understand its theory and practical very clearly, and after you will understand it, you can build your own Java program very easily. So meet you in the next session. Thank you so much.